Okay, so let's look at adding and combining functions in different ways. So for instance, right here, for example A, we've got two functions. We've got g of x and f of x. So let me kind of highlight these a little bit for us, make them a little bit easier to read. And the first part of this is actually asking you to, do you understand function notation? And I'm hoping the answer is yes, but if it's not, then let's go through it. Another way to think of this, instead of f plus g of x, is really that's f of negative 1 plus g of negative 1. It feels like you're distributing. I mean, I can't say don't do it or don't think of it that way, but really it's just different notation for adding up the two functions. Now, to find g of negative 1, we're going to go over here. Find f of negative 1, we're going to go over here. So f of negative 1, it looks like it's about 1. G of negative 1, 2, 3, 4, looks like it's about 4, so a total of 5. Yay, and that's it. Nothing really drastic there. Hopefully some easy points for you on an exam. Just figure out what's the value of the function here. F minus g of 1. Let's rewrite that another way. This is the way a lot of books are going to write things. I like writing it like this. F of negative 1 minus g of negative 1. Because it's just a little bit more concrete, a little less abstract. Now we already know the values for this, so that's going to be 1 minus 4 or negative 3. What do you think this next notation is asking us to do?
Multiply.
Yeah, it's multiply. So it's going to be f of negative 1 times g of negative 1. So 1 times 4 is 4. And then the last one, of course, would be division. That's going to be f of negative 1 divided by g of negative 1, which is going to be 1 divided by 4. And that's it. That's all that's going on there is just some notation. Oh, good question. So g of negative 1, so that's the origin. Here's negative 1. If I want to find g, I went all the way up to the function of g and seem to be at a height of 4. So that's where I got the g of negative 1. All right, appreciate you asking. Let's keep going. Again, with some function notations, they ask you to find f plus g, f minus g. I'm trying to think, is f plus g is actually kind of interesting. And I think I have this one on Desmos for us. So here's f of x. Let me make that a little bit darker. There's f of x. Here's g of x. And something interesting happens when you add these things together. Let's see if we can't make sense out of it. So let's start by finding f plus g of x. And even though I might write it like this, there's nothing wrong with thinking of it like this, which is going to be 3 minus x squared plus, where is it, x squared minus 4. Can anyone simplify that for me?
Negative 1.
Negative 1. So interestingly enough, what would the graph of, say, y equal negative 1 look like? Yeah, just a nice horizontal line. If you actually take a look at the combination of those two functions, bam, that's exactly what you get. It's just a nice horizontal line. So no surprise there. I think you've got the notation part of this down. Maybe we'll just do one last one here. We'll do f times g of x. And I also want to look at the domain part of this one. So f dot g of x, that's going to be f of x, 3 minus x squared, times g of x, x squared minus 4. I probably want you to FOIL this out. You're multiplying binomials together, so that's going to be 3x squared minus 12 minus x to the fourth, and then plus 4x squared. Yeah, minus and a minus, it'll be plus. So overall, I get negative x to the fourth plus 7x squared minus 12. So I'd be looking for that as an answer, especially if I say simplify as part of the problem. I'd probably give you a partial credit if you just wrote them next to each other. But if I wrote simplify, I want this last answer here.
You always want them in descending order too, right?
There's a good reason for putting them in descending order, and that is I can tell you a lot about this function just by the way it looks. For instance, it has to have a shape that looks like this somehow. That is, eventually it's going to go down on both ends. I know from looking at it that's an even function, so even if I'm off on some of this, it is going to be an even function. What else can I tell you? You can start guessing at some of the roots. So there's a lot that you get, but it all comes from that first term, as long as it's in descending order. So great question. Yeah, I do like it in descending order. It's also helpful for you though, so that you know and understand a lot of things about this function. Let me move on to the last piece of this, which is the domain of f divided by g. So f divided by g of x would simply be 3 minus x squared over x squared minus 4. And I want the domain of this. So, what's the domain? Or what problems might I have with the domain for a function like this?
0 in the denominator.
0 in the denominator. So where is x squared minus 4 equal to 0? 2 and negative 2. Yes, thank you, gentlemen. X squared equals 4, x equals plus or minus 2. So is that my domain? No, I want to avoid those points, right? That's the problem child for this function, right? That's the one that you want to avoid. Yeah, you're going to have asymptotes there. Thank you, Ben. So our domain is everything but those. You could write it a couple ways. If you're going to write it with interval notation, you want to avoid these 2 points. So maybe it's helpful to look at this and realize that your domain is, negative infinity to negative 2, union, negative 2 to 2, union, 2 to infinity. Wow, nice. So a little bit of review there for you on the domain. We're going to continue working with domain. Are we okay with that one? Let's move down to example C. We've got f of x as the square root of 16 minus x squared, and g of x as the square root of x plus 3. Let's find the domain of each of these. I'm going to start with the easier one first. So as far as finding the domain of this, what problem could I run into with the function g of x? Caitlin, what could go wrong here? One more time. What could go wrong when you're trying to take the square root of something? What do I have to worry about? Yeah, I have to worry about a negative. So I want to make sure that this is positive, so I want x plus 3 to be greater than or equal to 0, which really means x is greater than or equal to negative 3. Okay, so that's our domain. I have a similar problem over here, right? I want to make sure that this is greater than or equal to 0. So 16 minus x squared is greater than or equal to 0. I can't solve it quite as easily as I did over here. This was just a little linear inequality. It's fine. This one, we practiced this. It was part of the first test. We want to make sure that this is greater than or equal to 0. First question is, where does it actually equal 0? What values of x would actually make this equal to 0?
4 and negative 4.
4 and negative 4. So 4 and negative 4. And this is where you do your testing of points. So you would take this expression here and test points.
So if it's a quadratic, that's when you would factor it if you're trying to find.
Find the roots, find where it's equal to 0?
Yeah. Okay, so like, I guess, what, I always forget, the radical is, does that dictate whether you factor or not either, or is it just?
It's just because we need to find out where this is greater than or equal to 0.
Okay, so you have to find where it's equal to 0, so, okay.
Yeah, you start by finding where it's equal to 0. What's going on here, Joe, and it's a good question, is that unless you're really good at visualizing the shape of this graph, it's easier just to realize that, all right, an equation like this can only change signs at certain points. And those points are right here. We already found them. The question is this function positive or negative in those intervals? So unless you're good at mentally viewing some of these things, and with a parabola you can be, but unless you're good at mentally picturing these things, you might want to put in some test points. Let's see, we're going to have something to the left of negative 4 would be negative 5. I always pick 0 when I can, and then 5. I'm not going to bother putting this into my calculator to test it. Let's just do it here. If I put in negative 5, that'd be 16 minus 25. Jay, is that going to be positive or negative?
Negative.
Negative. If I put in 0, positive or negative?
Positive.
And then 5 is going to be the same as negative 5, so thank you, Jay. So negative, positive, negative.
Does it always alternate with parabolas?
Yes. The only time it wouldn't alternate is if you had something that just touched the x-axis at one place. So, for instance, something like if I had x plus 4 squared, all right? The graph of this is just going to touch the x-axis right here at negative 4. So if you're testing here, it would go positive and then 0 at that point, and then positive again. So it wouldn't necessarily alternate if you had a repeated binomial like that. I want the positive interval, so that's negative 4 to 4 is my domain. Domain. That's where this is defined. Okay, so a lot of work there to find the domains. I'm going to bring it back to kind of a nice visual thing in just a second. But you're okay with our work to find the domains. In both of these, we've got to make sure that the graph, or excuse me, that the radicand, that is that expression underneath the radical, that has to be greater than or equal to 0. We did that. We did that here, and we did it down here. The question is, where do those things overlap? Because when you look at the domain of f plus g, domain of f plus g is only going to be defined when both of those are defined. So where do they overlap? So where do the domains overlap? let's graph it and see if we can't figure it out. So on the one hand, I've got a domain from -4 to 4. That's the domain for this graph, and I'm sorry I didn't need to include all this here. There we go. Never happened. And then the other one, the other domain is from -3 to infinity. The question is, where do these overlap?
-3 to 4?
Yeah, -3 to 4. That's where they overlap. So put that right in the middle. And I can use both endpoints because at -3, well, square root of 0 is defined. Or at 4, square root of 0 is defined. So your domain of f plus g is -3 to 4. And it's exactly where those things overlap. Let's take a look at things graphically and see how that plays out. So I'll shut off this one. Here's the graph of the first function, which should kind of look familiar, right? What does that graph look like? Top half of a circle, maybe? Yeah, a semicircle. And here's the graph of the other one. So notice where these are going to overlap. They're going to overlap right here. And so when I turn on the function t of x, which is really the sum of both of these two, it should only be defined in the interval -3 to 4. And let's see that that's true. There you go. So this function is really obtained by adding points. If you take this point here, which looks like the square root of 3, and add it to this point here, which is 4, square root of 3 plus 4 should be about 5.732. And there you go. That's how you get this point. This point here is really just square root of 7 plus 0. So you're getting these points for the green function by adding these other points. Let me shut these two other graphs off so you can see that this function is only defined from -3 to 4. That's the addition of those two. Joe, did you have a question?
No, I'm just moving around.
Okay. Trying to loosen up the cogitations. All right, got it. Anyone else? We okay on that one? It's just like overwhelming after we took a test on Tuesday. It's, oh, I'm not ready for all this stuff today. This is heavy thinking. Let's take a look at kind of a modified version of this. What would happen, what would change if instead of just looking at the domain of r plus s, I like the domain of r divided by s. There's the ratio of those two. Would that still have the same domain? And the answer is no. But why? What else could go wrong if I were to look at, the ratio of these two functions? For us, it'd be f of x divided by g of x. I ran out of letters for this.
You can't have zeros in the denominator.
Ah, you can't have zeros in a denominator. So let's see, page 7 here, f of x divided by g of x, square root of 16 minus x squared. Let me switch screens here for you for a second. 16 minus x squared, square root of x plus 3. Here the domain was -4 to 4. Here the domain was -3 to infinity. We already know where that overlap. But by virtue of this being in the denominator, we can't let g of x equal 0. So the question then becomes, well, what value of g of x, or excuse me, what value of x puts a 0 in the denominator? Yeah, 3. So g of x equals 0 when x equals 3. Or negative 3, I should say. Nice. So that means your domain for this function, so the domain for f divided by g of x wouldn't be negative 3 to 4 like it was in the last one. It's going to be negative 3 with a parenthesis there, because you can't include that negative 3.
So you're like adding on to the last one, basically.
Yeah, you kind of upping the game a little bit, because you got to be aware of the fact, oh, well, I can't have a 0 in the denominator. And for giggles, let's just take a look at the graph. The graph should not be defined at x equal negative 3, right? So here's that graph. And if you take a look, what kind of feature is it that you see near negative 3? What do we call that? Does anyone remember?
Asymptote.
Vertical asymptote. Yes, well done. Vertical asymptote. Yep. All right. Let's move on to example D. So example D looks like this. Square root of x plus 5 minus the square root of 8 minus x over x. So right away, you know you're going to have a problem. At what point? What point here is going to give us a problem, Max? What value for x is going to be a problem in the domain?
Five and 0.
0. That's the one I was looking for. Thank you. 0. Because this denominator would be 0, meaning this ratio would be undefined. So we're going to have a problem at 0. You should see, for instance, a vertical asymptote near there, and we do. We see a couple other weird things going on. Now, this is kind of unusual. I think this graph should actually, no, maybe not. No, it is actually defined at negative 5. It's also defined at 8. But let's take a careful look at the domain here and all parts of it, try and understand that. So example D. F of x equals the square root of x plus 5 minus the square root of 8 minus x over x. And let's take care of a few things here. For instance, the first thing I want to guarantee is that x plus 5 is greater than or equal to 0. That's going to happen when x is greater than or equal to negative 5. Okay, there. How about over here? I want to make sure that 8 minus x is greater than or equal to 0. A couple ways you can do that. What way would you use? How are you going to get x by itself here? What works for you?
Subtract 8 from both sides and then divide out the negative.
All right, subtract 8 from both sides. Negative x is greater than or equal to negative 8. And then divide out the negative. Awesome. Thanks, Nate. Somebody tell me what special thing is going to have to happen when I divide out that negative. Yes, thank you, gentlemen. The sign's going to flip, so it's x is less than or equal to 8. And finally, there's one more little trap that we got to be worried about. X can't equal 0. So we got all three things we got to worry about. This is a problem. We want a restriction here and a restriction here. So let's graph each of these things and see where this overlaps. So I want x is greater than or equal to negative 5. So I'll put a little solid dot here, negative 5, and then an arrow to the right. And then I want x is less than or equal to 8. Solid dot here, arrow to the left. I think I can see where these are overlapping. And a hollow dot at x equals 0, because it can't equal 0. So let me make that a little bit more clear that I'm omitting that point. Your domain would then be -5 to 0. What kind of special notation am I going to use around the 0? Thank you. Parenthesis. Union 0 to 8 with a bracket. There's your domain. Beautiful. Whew. That was a good one. That was a good one. Okay. Comments on example D? Hamza, doing okay? Josh? Thumbs up? All right. Not always. Not always. I mean, it's going to depend on the problem. Sometimes you have closed brackets on both ends. For instance, the one we just did a moment ago, if this was my function, just this part of it, then it'd be -4 to 4 with a bracket. That's the domain of f of x. So it can be closed, it can be open. It's really going to depend on the function. It's not something I could give you a broad rule for. So appreciate the question. Let's move to example E. So this one is just really asking you to add a couple functions. No, that's g of x, my bad. That's g of x, here's f of x. And on WebAssign, you're going to be given, a couple choices. What you're going to have to do to try and decide, well, what's this going to look like, is maybe pick a few points and add them and try and envision what it's going to be like to add up those points. So for instance, what does g of x look like at, let's see, 1, 2, 3, 4, 5, 6. So what's g of 6 going to give me? G of 6 is going to give me 2. F of 6 is going to be -2. So if I have f plus g of 6, that's going to be f of 6 plus g of 6, which is going to be -2 plus 2. I should get 0 when I add these two together. So just working with that, I can eliminate this as a choice, right? Because it says f plus g of x, or f plus g of 6, looks like it's about 5. So this can't be it. That's the wrong graph. And for the same reason, this would have to be the wrong graph. There's also another reason you can see that this one's the wrong graph, and that's because at the origin here, or at x equals 0, when you add f plus g, you should get something bigger than each of them, not something equal to f. And of these two last choices, only one of them has the right value of f plus g of x at x equals 6. So this one's your winner. So really we only needed to look at one point when we're looking at these graphs. Are you comfortable with domain and range? What we've been doing here, combining two functions and finding their combined new domain. So stuff like this, or do you want to practice this next one? Find the domain of 1 plus x and 1 minus x. Want to give that one a try? All right, why don't you do that? try and find the domain of this function. So if you're watching this later, you can kind of fast forward until I unpause. Here's my high-tech pause button. It's pretty cool. Qué chistoso.
What's the graph? Find the functions, figure out what the domain is based on just looking at the functions. You can kind of confirm it by looking at the graph, but you might not have a graph on the exam. That's right. Yeah, -4.
Yeah, you should, it's like, -1.
Okay. So let's finish up example F here. So the first thing I want to know is where is 1 plus x greater than or equal to 0? And that's going to be when x is greater than or equal to -1. And then I'll look at the other function and try and decide, well, where is 1 minus x? Oh, don't do this to me. Where is 1 minus x greater than or equal to 0? Probably an easy way to do this is to move the x to the other side because it makes it positive. But then this is opposite of what you're used to. You can flip this whole thing around. Remember, alligator eats the bigger number. 1 is the bigger number. If I flip it around, 1 should still be the bigger number, and it is. Now I can look at these and see, well, where do they overlap? So let's draw ourselves a little number line here. We're going to put two numbers on it. -1 and 1. So for the first inequality, I've got everything greater than or equal to -1, so that's going to be up here. For the second inequality, I've got everything less than or equal to 1, so that's going to be down here. And they overlap at this region right here in the middle. So that's where they overlap. -1 to 1. So that's your domain. -1 to 1. You can see that when you look at the graph. That's where the graph is defined. Here's your graph. It's defined from -1 to 1. One thing you have to be a little bit careful about in looking at this is realizing that this is a unit of 2. So that'd be your -1, that'd be your 1. So nice, nice. Okay, a couple more to finish up. Again, going back to some function notation, this is called iteration. When you put in a number to a function and then take whatever the output is and put it back into the function, it's called iteration. And it has some nice applications, but right now let's just blast our way through this. The way you work these things is you start from the inside out. And the inside would be finding f of 2. So let's see if we can't find f of 2. So it's going to be, let's see, still not working. F of 2 would be 4 times 2 minus 3. So 4 times 2 minus 3 is 8 minus 3, which is 5. So, okay. This part then, f of 2 is really the same as f of 5. So let's put in a 5 here now. Because that's what f of 2 is equal to. F of 2 is equal to 5. So those two, oh, I'm sorry, I was off the screen on that, my bad. Thank you. So one more time, f of 2 gave me 5. So instead of writing f of 2 here, I could write that's 5. Now I want to look and redo this for the value of 5. This is going to be 4 times 5 minus 3. What's that give me? I think somebody said it. What was it?
17.
Yep, 17. Thank you. And there you go. It's just plugging that value into the function essentially twice. Let's try it again with g of x. G of x is starts out the inside with g of 3. So let's find g of 3 to begin with. G of 3 is going to be 5 minus 3 squared, which is 5 minus 9. What's 5 minus 9 going to give me? -4. Nice. So g of 3 and -4 are interchangeable. So now I can write this as and figure out, well, what's g of -4? G of -4, go back to the rule for g. That's going to be 5 minus -4 squared, which is going to be -11. -4 squared is 16. It's not -16. -11. So that's your answer for that one. So here's the answer for the first one. There's the answer for the second one. All right, getting near the end here. I like this one because you can't do this one with just, say, I don't know, photo math or anything like that. You actually have to do this one. It's asking for f of g of -4. This notation, by the way, also goes by another notation. You could write that as f composed with g of -4, and that's fine. It means the same thing as f of g of negative 4. Now, if you're going to do this, we're going to do this the same way we did the last one. Work from the inside out. And that is, all right, let's start there. Can someone tell me what g of negative 4 would be?
3, right?
0.
Let's see, 1, 2, 3, 4. Looks like about here, right? And at least in my graph, it looks like g of negative 4 is 3. So that's equal to f of 3. So let's work with f of 3. So now we're on to the graph for f. Here's f of 2. What would f of 3 be? Kind of unsatisfying, but all that work for nothing, right? All right. Example I, another one that you could see on your homework, is asking you to do the same thing except using a table. So it's got all the values you should need. So keep that in mind as you're looking at it going, wait a minute, this doesn't work. It will work. This is going to give you all the different values you're going to need. Where should I start? Good. Start with the inside, which would be f of 2. If you look at the table, what's f of 2 going to give you? F of 2 is going to give you 3. So let's plug in a 3 here. Then I got to look at the table and find g of 3. What's g of 3 going to be? Let's see, who haven't I heard from in a while? Dalen, what's g of 3 going to equal, please?
4.
Perfect. So here's your 3, there's g of 3. G of 3 equals 4. Awesome, nice. Now these last two are probably the trickier ones. I mean, it's not like a really big value problem on a test. But if you can start to get used to this, it's going to help you out for your calculus class, because you're going to have to view a lot of these functions, not as just functions, but functions of functions. You're putting two things together when you create this. And it's probably easier to start with the second one first. So let me start with example K here. What they want you to do is they want you to come up with two functions so that when you put them together, when you form f composed with g, that you get this new function h of x. Now personally, when I look at this, I see two things. The first thing I see, maybe it's the first thing that you see. When you look at h of x, what's the first part of this function that you see?
The absolute value.
The absolute value. That's kind of your outside function. Now your outside function is going to be your f of x. So let's do f of x equals the absolute value of x. The rest of that has to be your inside function. So thanks, Dean. What's the inside part of this going to look like? Malik, what do you think the inside of this is going to be? What's g of x? Once you get past the absolute value, what's left? So you got the absolute value here. What else is there about this function? What's inside the absolute value? 1 minus x to the 4th. And if you put these two functions together and said, oh, h of x is really f of g of x, you'd be right. Because you're taking this, plugging it in for g of x, 1 minus x to the 4th, and then f of x says, oh, take the absolute value of whatever you put in here. So it's going to be the absolute value of 1 minus x to the 4th. So, yay. That's how you put those two together. that was the easier of these two. This one's the harder of the two because it's not so clear what the outside function is and what the inside function is.
Can you move it over to the, I just wanna see the left side of the page. Okay, thanks.
Now looking up at example J, we want to find capital G of X. Again, there's two pieces to this function. What's one thing you're seeing when you're looking at capital G of X here? Can anyone give me a name to maybe the first function that you're seeing here?
Linear?
The bottom part of it's linear, but overall, the whole thing is not going to be a linear function. It's a good try. Well, one thing you could say is that, well, the first thing I see is I got 1 over something, meaning I'm taking the reciprocal of something. So my outside function, the first thing I see is that I'm taking the reciprocal. What does that leave for the second part of this? X plus 1. And if you put those things together as f of x plus g, or f of g of x, you're going to get this. You've got to get the order straight though. If I had these things reversed, it wouldn't give me this. But in this order, it does work. Let me show you if you had these things reversed, why WebAssign is going to mark it wrong. If I did f of x is x plus 1 and g of x is 1 over x, what would f of g of x look like? Well, here's your function composition practice. Start with the inside function, that's 1 over x. And now go to the rule for f of x. The rule for f of x says take whatever you put here and add 1. So what that's going to be is 1 over x plus 1. And that's not quite the same as what I've got here. This is done the right way. Okay, comments or thoughts on that last one? Let me shut this one off and put this one in the books.